Hi, everyone. This is Andrew, software engineer and software developer for Silicon Valley companies like Microsoft, LinkedIn, Snapchat, IBM, BlackBerry in San Francisco Bay Area. I'll be your instructor for the course, Software Engineering Interview Prep. So if you're targeting for software engineering role at top tech companies, I highly recommend you attend the course. This course is absolutely for free and will cover everything from software engineering to technical interviews to coding questions to go-to-market strategy. So during this course, I will cover important topics, most asked interview questions, and efficient ways to solve them. So I have more than 7 years in software engineering at top tech companies in the United States, and I have helped a lot of candidates with interview preparations. So I'm excited to help to land your dream role. Sign up for my course, and I'll look forward to meeting you in the many more sessions. So let me give you a quick intro and overview of HiCounselor. HiCounselor is an online career accelerator that helps job seekers find a full-time job, as well as internships. HiCounselor helps candidates with interview prep as well as getting the interview calls. So we utilize AI-powered job search tool and strong network of more than 300 employers to help candidates land a job. So every candidate gets a personal attention and mentorships from professionals like myself who come from top tech companies. The payment structure at HiCounselor is an income share agreement where you don't pay anything to HiCounselor until you land a job. Once you land a job, you pay 9% of your first salary in 6 monthly installments, so there's no upfront payment. If you're currently looking for a job, HiCounselor is a great resource for you. So next cohort at HiCounselor starts very soon. So if you're interested, please apply on HiCounselor.com. Use my code Andrew, ANDREW, and you will get $500 discount when you start paying HiCounselor after landing the job. So in this session, we're going to go over Silicon Valley startups most asked technical and coding questions. So this is my curated list of coding questions and technical questions that I got from startups, whether they are early stage Series A startups or late stage startups that are unicorns. So we'll go ahead. The first question that I have in my backlog is, well, is the use of word synchronized in the context of Java. So what does the synchronized keyword mean and where would you use it? So you get this question quite often in the phone screening and technical screening. So essentially, a synchronized keyword in Java defines a thread-safe operation. It can be used on instant methods, static methods, and code blocks. So the synchronization or thread safety is achieved by allowing a thread to acquire and release an intrinsic lock. So while the thread owns the intrinsic lock, the other threads that will try to acquire it will be blocked. So this is synchronized Java, one of the most asked coding phone screen questions. So when we apply this, the synchronized version of hash map is actually hash table. So once you have a thread safe operation, and we said it could be used on instance methods, static methods, and code blocks, you can achieve hash map synchronization by allowing a thread to acquire and release an intrinsic lock as it's done in hash table. Okay, so we discussed thread safety. So what's a deadlock? So deadlock is a situation where two or more threads are waiting for each other and they are blocked forever. Okay, so these are a couple technical phone screen questions I wanted to throw, and let's move on to a coding question. So given So given an array nums of length n, so you want to create an array answer of length 2n, where answer I is equal to numbers. Okay, so you want to create an array answer of length 2n, where answer at I is equal to number at I. So you also want to make sure that answer at I plus n is equal to numbers at I. So you can see that answer is the concatenation of two numbers arrays. So let's do an example. Let's say you have an input of numbers at 1, 2, 1. The output's going to be 1, 2, 1, 1, 2, 1. And the reason being is that the array answers is formed like the following. So the answer is going to be 1, 2, 1, 1, 2, 1. This is why. Because you're creating an array 2n where answer at I is equal to numbers at I, and answer I plus n is equal to number at I. So this is a fairly easy question. So I'll give you around 2 to 3 minutes to think about how to approach this question, and then we will solve together. All right. Okay, so one of the ways to approach this question is you can optimize by using a once for loop and then using a modular operation. So we'll start with a raw solution, and then after that, we'll try to make some optimizations to it so that you're not iterating twice the size of the original array. So the most straightforward solution is you have your argument numbers, and then you have your result array variable. So the size is going to be numbers length times 2. And then for all the way from beginning to the end, you can do x modulo numbers length, meaning you divide x by the size of the numbers, the length of the numbers, and then get the remainder, and then use that as the index of the number. So essentially, because you have the new size bigger than the original size by 2, by a factor of 2, all you have to do is get the current index and divide it by the number's length, and then get the remainder, and then that remainder is going to be retrieved from the numbers and inputted into the result array variable, and then obviously you return result. So what's the optimization? So the above solution is looping twice the size of the original array. So when iterating, you can bring down the size of the arrays as much as possible, not the other way around. So what does that mean in terms of code? You can actually do int equals 0 all the way from 0 to the end. Right? So the result is going to be, result at x is going to be equal to numbers at x. And then result at x plus the numbers dot length is going to be numbers at x, because we are using the property of the question, which is that the result array is twice as big in terms of the length as the numbers. So the result at x plus numbers length is going to be the numbers at x. So you're not iterating twice the size of the original array. You're only iterating a version that is cut down in terms of the size of the array. So here you can see you're iterating numbers dot length times 2. You're iterating numbers dot length only 1. So this is much optimized. Okay, so this is one of the questions, and then let's try another one. So in this question, you are given a zero-based permutation numbers. And then you want to build an array answers. you want to build an array answers of the same length, where answers at I is equal to numbers at numbers I, and then what's called a zero-based permutation is that the numbers is an array of distinct integers from 0 to numbers length -1 inclusive. Okay, so you're given the zero-based permutation numbers, you want to build an array answers of the same length, where answers at I is equal to numbers at numbers I, and zero-based permutation, it means it's an array of distinct integers from 0 to the end. So let's try an example. The numbers. So you have numbers of, let's say, 0, 2, 1, 5, 3, 4. What's the answer going to be? Answer is going to be 0, 1, 2, 4, 5, 3. And explanation is that every answers is built as follows. Okay, so remember, this is the formula answers at I is equal to numbers at I, and then you're producing the answers from that array numbers. And you get these different indices, which produces another set of numbers. That way you get 0, 1, 2, 4, and 3, 5, and 3. So let's try this. This is, I would say, between easy, medium question. And then I'll give you 3 to 4 or 2 to 3 minutes to think about it, to come up with a thought process. And we'll solve it together. Okay, so in this solution, you can use Java's streams library, or you can have naive O-event solution that practically appears in full. So simple solution would be like this. But you can optimize this to solution, and that's the whole point of this problem, is to optimize rather than just straight up iterating through the whole thing. And to meet up the requirement of O-event space complexity, you can achieve this with less space. You can rely on a bit shifting, which is something which is possible due to low values in numbers. So if you want to do bit shifting, you can actually do this. So this is a decimal value of the binary number 1111. 11111. This is what it is. And from 0 all the way to the end, so essentially you have a decimal 1000, which is max value of numbers, as a binary, which is 1111. Let's say 111110111. So let's say you have a decimal of 1000, and then your binary number representation is going to be as such, right? All of our values will be fit into 10 least significant bits, or 10 least sig bits. And then in the first loop, you're going to have numbers I equal to 10001 00011, which is this portion. Okay, which is this portion. Now we're going to have the latter part, which is going to be as such, and that's going to be that part to be numbers at I, right? So in the second loop, You have everything. But your bit shift operation which is this part. So that's going to correspond to this portion. Okay. So in the first loop, you're experiencing this for loop, and then the second loop, it's going to run this statement such that you get 1 0 0 0 1 0 0 0 1 1. Now there's a simpler solution, but this solution is not the point of this question. So you can actually use Java's built-in library which is as such. Arrays a string, and then you map that. To array. Right? So obviously, this is much more concise. However, the point of this solution is to come up with a very naive solution and then optimize it such that you run the whole code with less space complexity. All right. So let's try another question, which is actually much more interesting and much more relevant to the real world problem. And you actually get this question a lot. So the question is, what is the maximum product difference between the two pairs? This is one of the most asked questions. So the product difference is defined as A times B minus C times D, right? For example, the product difference between 5, 6 and 2, 7 is going to be 16, right? Because A times B minus C times D. So given an array of numbers, you need to choose 4 distinct indices. W, X, Y, Z, such that the product difference between the pairs numbers W and numbers X and numbers Y and numbers Z is maximized. So choose a 4 distinct index so that product diff between pairs and is maximized. Okay, so for example, let's say you have number 5, 6, 2, 7, 4. This is going to give you 34. So you need to choose indices 1 and 3 for the first pair and indices 2 and 4 for the second pair. That way you get a product difference that's maximized is equal to 34. So I'll give you maybe 3 to 4 minutes to think about how you can approach this, and then we can solve this problem together. So there's two solutions to this. Number one is you can do this. You can get the maximum product difference by having time complexity of O of n log n. So time complexity of O n log n, and it's going to look as follows. You first sort out the numbers, okay? And then you just simply return the last element times the second last. It's pretty simple. This is a pretty simple mathematic approach, minus the first two, right? So this is the most simple, straightforward solution. Now, how do you achieve this without actually sorting it? Longer way. And you achieve this by getting the largest, next largest, smallest, and then we're going to set that to the maximum value. Second smallest. So we're going to go from, as usual, from the beginning all the way to the end. And we're going to say if the largest is actually less than the current element, then we're going to update the next largest to be the largest and then the largest to the current element. It makes sense, right? Now, if that's not the case, if that's not the case and the current element at I is actually larger than the second largest, then we simply say next largest is equal to the numbers at current element, right? So once this if-else if statement is done, we need to do another one, which is to say the same logic, apply the same logic for the smallest elements as well. So if the current is less than the smallest, and then if that's not the case, we compare the numbers with the next smallest or the second smallest. Doesn't matter what variable nomenclature you want to apply. Right? So the next smallest number, second smallest, is going to be numbers. We update as such. And then we simply return the largest times the next largest minus smallest times the next smallest. It's a pretty straightforward solution. So this is the longer way, and then the shorter way is obviously just to sort it and then get the last two bits and then the first two bits and then multiply that and then subtract that. So I want to really thank you for your attention as always and your participation. You guys are always here. So again, if you need assistance with job search, HiCounselor is an amazing resource for you. I come from big tech companies like Microsoft, LinkedIn, Snapchat, IBM, and I've been there. I've been through all the job search process and been in the experience of struggling to find the right recruiter and finding the right job. So I wish I could be of help. And the payment structure at HiCounselor is an income share agreement where you don't pay anything to HiCounselor until you land a job. So only when you land a job, you pay a small fraction of your first year salary in monthly installments. So there's going to be no upfront cost. And then the next cohort starts soon. So if you're interested, please apply on HiCounselor. Feel free to use my code Andrew, ANDREW. And then you will get a large discount when you start paying HiCounselor after landing the job. So with that said, I want to throw one question for you to work on your own after we finish the session. And it's pretty straightforward. Again, this is a typical questions that's asked by startups in Silicon Valley. So the question is, given the integer array numbers, your goal is to find the biggest common divisor of the smallest number and the largest number in the numbers. Again, you want to find the greatest common divisor, or GCD, of the smallest number and the largest number in numbers. So obviously the greatest common divisor of two numbers is the largest positive integer that evenly divides both numbers. So this is a great question and can be applied to many other mathematics coding question. So it's going to help you once you think about it. All right, so I'll see you guys again. Thank you so much.